The unit circle and trigonometric ratios. The goal of this lesson is for you guys to understand the unit circle entirely, right? How to solve using the unit circle, how to go backwards using the circle. It's a big part of mathematics. And the first step to doing that is to know more about right triangles. A right triangle is a special triangle that has... That's kind of cool. Not gonna lie. It's kind of cool. So a triangle has three sides, and the right triangle is a special triangle where one angle has to be 90 degrees, right? So like the little mark here means 90 degrees. Now the key to my right triangle, you gotta know how to label it. So let's say this is my angle. That's angle A. And so theta there. The side opposite of this is called opposite. Here's your right triangle. Across from the 90 degree angle is your hypotenuse. And that means the remaining side is adjacent. Right? So every right triangle is labeled like this. So once you find your angle, side opposite is opposite, hypotenuse is the right angle, right opposite right angle, and the remaining side is adjacent or next to. Now, every time you look at a triangle, you have to understand, first thing you go, okay, what's opposite, what's adjacent, what's hypotenuse? It takes a split second once you get used to it, but that's kind of the first thing you want to look at. So let's do a quick example here. Let's draw another right triangle. Kind of like this. So cool. And then let's make doesn't really matter. Let's take this one to right angle, right? And then let's have this bottom side. Let's make this side my angle. So that's my angle A. So right, that's my angle A. Here's opposite. Here's hypotenuse. Here's the right angle. Sorry, here's 90 degrees. So here's hypotenuse. Right, and then the remaining side is adjacent. These are all important. We have to know those because trig we have these things called trig ratios, which are sine of my angle theta is opposite side over the hypotenuse side. So whatever the length of that side is over the hypotenuse, that ratio is going to be sine. Then we have cosine of theta, which is the adjacent over the hypotenuse. And then we have tan, which is opposite over adjacent. And the easiest way to remember this is one of my favorite things about trig is SOHCAHTOA. Right, where sine stands for opposite, S stands for opposite of hypotenuse, cosine is adjacent of hypotenuse, and then tan is opposite of adjacent. SOHCAHTOA. You're going to be saying this to yourself a lot in trig. We just always use it. It makes life so much helpful, so much more. It makes remember the trig ratio so much easier. It's never going to stop being cool. I'm sorry. So with that in mind, let's do an example real quick. Height of a flagpole. Right, so here's this flagpole. Let's try to find the height of this flagpole here. It's Barcelona. It's Brazilian flag because international IB. So you want the height. The way you do a problem like this is a fairly straightforward problem. Is you go, okay, what do I have here? Sine, cosine, or tan, right? So I got to go. Let's list out the sides. So here's my angle. It's a right angle, so I could do this. This is opposite. This is hypotenuse. This is adjacent. Right, then you look at what you have. We have opposite. Well, we're looking for opposite, so we're going to circle that one. Sorry, it's not going to be, it's always cool. When we have hypotenuse, right? So opposite, we have hypotenuse. So we look at we think SOHCAHTOA. And opposite of hypotenuse, O and H, right here, right? This is a sine function. We have opposite of hypotenuse, right? Only thing that has O and H is sine. Cosine is adjacent to hypotenuse, tan is opposite or adjacent. So we're doing sine. So the way this works is like this. You go sine. It always has to be sine of something. So sine, in this case, 53, equals opposite of hypotenuse. So x over 30. Right, if I want to solve this, I multiply both sides by 30. I do want you to notice that this is in degrees, so make sure your calculator is in degrees. We're going to flip back and forth between degrees and radians a lot. In this case, how do you know when you do degrees? Well, you see the freaking degree sign. That's kind of the hint. The little degree sign, that's the hint. So it'll be 30 times sine 53 in your calculator. You get some answer. I really don't care. You guys put that in your calculator. And that's the idea, how to do that one. before we move on, I want to go backwards a little bit. So let's do one where, so cool. Let's do one where I give you the sides, but we don't have the angle. So let's like make this our x, right? And let's put two sides. Let's say this is 4 and this is 7. Let's try to figure out what the angle is. That's a 7, not an x, sorry. In this case, right? So I'm just going to focus down here. Here's my angle. So let's lace out the sides. This is opposite, right? Across from my angle. This is adjacent. There's an ugly 7. And here's my right angle, so there's hypotenuse. Again, SOHCAHTOA, we have opposite, and we have adjacent. So O and A is tan. So we're going to go tan of my angle. It always has to be tan of something. You never have sine, cosine, or tan by themselves. It's always tan or cosine of something. And then opposite of adjacent, so 4 over 7. Then the way we solve this is we want to get rid of tan. There's a tan there. We want to get rid of it. So what we do is we do inverse tan or arctan. They mean the same thing. So you go with tan -1, or if you prefer, arctan. Again, they mean exactly the same thing. On your calculator, you see this. So you do tan inverse of both sides, and then you get your answer, which will be in if you have your calculator, it'll be in degrees. So that's kind of the idea. So that's the basics of right triangle. Now let's move on to the big thing. Let's move on to the reason we're here, the unit circle. So the unit circle is something we're all going to know how to do. Like, it's going to come up a lot in calculus. It's come up a lot in pretty much any other math class besides stats you can take in the future. And it's something you have to have down. It's kind of like doing powers, where like, oh, you can speak 2/3, you should know it's 8. Same with the unit circle. If I say what is sine of pi over 3, you're going to have to know that's right 3 over 2. Right? So there's 3 ways to go about this. Again, there's no going around it. And there's every single way is going to require some type of memorization. There's like no shortcuts. And it's kind of, I'm going to show you all 3 ways here, and you kind of just got to decide which way is best for you. I'll tell you right now, I think most people are going to use the table, which is totally fine. I don't care which way you do this. I tend to do the triangle way. It's a little more advanced. And then the way, if you hate yourself, I guess, is to memorize. So some people just memorize it. I joked a little bit, but it's actually not that bad if you look at it. It's all the same. Like there's only like 4 different numbers. So you notice, you start noticing patterns, and you kind of just learn how to memorize it. So that's one way, just straight out, just memorize it. That's one way. Again, there's not really much I can say about that. It's just that you notice that there's patterns, it kind of repeats. It's not that bad. I do the triangle way, and I'll talk about that in general, and then we'll finish off and I'll tell you about the table. And again, my prediction, in general, I think you guys, what most people like is the table. So given that there's these 2 main different ways, there's a couple things that no matter which way you do, you're going to have to know. Right? Like the first thing is, no matter which way you do it, even if you do the memorize, you have to know your degrees and radians. So degrees, so right here, let's say this is degrees, right? So so a couple things, when we start graphing this, it's on a normal XY plane. Notice right here, it's an X and a Y. It's a normal XY rectangular plane. So we always start, let's get to build this, we're always going to start at 0, no matter which way you do. If I give you a positive angle, then you're going to go up. So like, right, it's kind of like this. Positive angle is going to go up. So let's say we want to get 60. We'll go like that. It's going to be my 60-degree angle. Right? So up from 0. If you want a negative angle, you go down. So you always start here. Negative angle, you go down. Let's say I wanted to go negative 60. Right? So negative 60 would be go down to like here. Because 360 minus 60 is 60. And that would be a negative angle. That's the way you kind of move. You always start on the positive x-axis. Positive, you go up and around. Negative, go down and around, right? So go counterclockwise, positive, clockwise, positive, negative. So when we talk about degrees, you're starting here, so this is 0 degrees. And then we get to halfway, well, that's a 90-degree turn, so that's 90 degrees. So you just add 90. Right, and then you go another 90, you get 180. Then you get another 90, you get 270. You go around again, fully, you get 360. You can keep on going. Just add another 90, you get 450. And then you can keep on going, you get 540, and then 630, and 720, and yada, yada, yada. You keep on going around. So that's how degrees look like when you go around a full circle. So you can keep in mind, positive, we go up. That's the default, right? So if it's positive, we're going to go up like that. We start here, you always start on the positive x-axis, and then you go up. Negative, you go down. Now if we're doing radians, So similar XY axis, nothing changes besides the way we measure it, the way we count it. So here's 0, no degree sign, just 0. Now a half circle is pi, probably the best way to think about it. So a half circle is pi. If I go around another half circle, I get 2 pi, then 3 pi, 4 pi, 5 pi, and so on. In between these two, well, there's 0 and pi, so halfway will be pi over 2. This is 0. This is pi and 2 pi. Halfway between those two will be 3 pi over 2, or 1.5 pi. Wait, just use 3 pi over 2. And that's generally the way radians work. You keep on going, same idea, keep on going longer and longer. Generally, when we graph radians, we want to use these two. We don't really focus on these unless we land on them. You want to use these. So if I say like something like 3 pi, you go 0, you go pi, another pi, and then 3 pi. Right? So that's how we're going to use it. So the next thing we all need to know how to do, no matter which way you do this, is what a reference angle is. So I wrote down the definition right here. Right, reference angle is the distance from the x-axis. Cannot stress that enough. You always go to the x, only the x, to the terminal side of an angle. So what does that mean? Let's say I gave you an angle that's like 210. Right, 210 degrees. So you start here, here's 0. That was an accident. Here's 0. Here's 180. 210's like over here somewhere, right? A little past 180. Doesn't matter how past right now. The reference angle is, well, how far is that from the x-axis? Again, it has to be the x-axis. So I would like to draw a little triangle here. And that's my reference angle. In this case, 210, 180, it's just 30 degrees. Notice that negative, it's not a negative value. It's just how far are you from the x-axis? That's always a positive value. So 30 degrees from the x-axis. That's what a reference angle is in degrees. So another one real quick. Right, so if I draw another crappy line right here, and let's say, it wasn't as bad as I thought it was going to be. What was that earlier? Let's say I found a reference angle for 300, right, so 300. Here's 0, again, positive, we're going to go this way, so this is 180, 270, 360, so it's in between these two. So again, I don't care where, just some idea, there's 300. Reference angle, we always go to the x, remember the y. So it's this, and you just figure it out, okay, 60 apart. That's my reference angle, 60 degrees. That's how you do in degrees. Now radians, it's a little easier. Again, this is another thing that no matter which way you do it, which way you memorize, you're going to need to know this. Now reference angle with radian measure is this. If it's, no matter what it is, if it's pi over 3, if you've kind of noticed when we did earlier, pi was like our 180, right? So pi is like the 180. So you always think about that. So it's like 180 over 3, which if you divide, 60 degrees. So that lets you know, no matter what, I don't care what number's on top, if it's divided by 3 in radians, it's going to be a 60 degree reference angle. If it's over 4, it's 45. 180 divided by 4 is 45. Over 4, there you go, it's 45. And then if it's over 6, it's going to be 30. 180 divided by 6 is 30. Now, again, no matter which way you do it, you're going to have to know your reference angles for radian measure. Now, people memorize this different ways. A lot of people do like, oh, it switches. I'm weird. I always think about it like a pizza. So you give me a pizza and you divide it by 3. Right? Pi over 3, I'm like, oh, I get a big slice. I get a 60 degree slice. If you get that same pizza and now you divide it by 6, so you cut this in half. Oh, now my slice is a lot smaller. It's a 30 degree slice. So I just think, oh, I'm dividing by a big number. I'm dividing by a small number. I get a big slice. If I divide by a bigger number, I get a smaller slice. So if I divide by 3, it's 60. If I divide by 6, it's 30. 45 is right in the middle. It's in the Goldilocks zone. Let's do a quick example. Let's find the reference angle for 13 pi over 4. Hey, it's over 4. It's 45. Done. Look how easy that is. Now, which is probably just as important, is how to draw this. So what quadrant is this in, right? Because when you notice when I did in degrees how to draw it, that's actually a big deal. Again, no matter which way you do it, it's gonna be a big deal. And we need to know the same thing for radians. So even though find the reference angle is super easy, over 3 is 60, over 4 is 45, over 6 is 30. Another big part of this is knowing where it actually falls. Where does 13 pi over 4 fall? And that's our next thing. It's how to draw radian measure. So one thing you can always do is convert, right? Convert to degrees and radians. I call this a baby way, so I don't ever want you to do this because you should have an intrinsic understanding of both of them. And that's my goal for you. But one thing you can always do is convert it. Here's this formula, right? So if you have degrees and you want to go to radians, so if you have degrees and you want radians, you just multiply by pi over 180. And that's really the trick to all this, is that pi over 180 thing. I'll explain more in a second. If you have radians and you want degrees, right, then you have radians, you're going to multiply by 180 over pi. That gets you degrees. So again, the whole key here is pi over 180. I just remember it like, let's say I wanted to convert 30 degrees to radians. I just remember, okay, I want radians. Radians generally has a pi in it, so pi should be on top. Pi over 180. If you do that correctly, you get 30 pi over 180. You can reduce if you want, and you get pi over 6, right? So I'm like, okay, I need to go in radians. Pi should be on top. You're going the other way around. If you have a radians, something like, I don't know, 2 pi over 3, and you want in degrees, then you know you don't want the pi, because degrees generally doesn't have pi's in it. So the pi should be on the bottom. That way these cancel out, and then do some math, and you get your answer, which will be 120. So that's one way to do it. Not the way I want you to do it, though. What I want you to do is just understand how to graph them. Because really all we're going to need to know is how to do these reference angles right there. So you need to know how to graph it. That's the next thing we're going to talk about. How to graph radians. Now, there's one key to doing this. Well, at least the way I do it. And that is common denominator. That'll make hopefully more sense in a second. So, let's say I give you this. Now again, when we draw radians, I really don't care about the top and bottom. That's going to only show up when I actually land there. All we're going to care about is 0, pi, 2 pi, etc. So the best way to do this is by example. Let's say that I want you to draw, I'm trying to figure out what quadrant it is in, 5 pi over 4. So remember my key is common denominator. So what I do is, I look at pi right here. Pi could be anything. It's like a number. It's like 1, right? Like if I want to add 1 plus 2 over 3, I go, oh, this is 3 over 3. Same thing with pi. If I'm trying to add, like, I don't know, 5 pi over 4 plus pi, I just go, oh, make this 4 over 4. And that's what I want you to do here. I want you to look at this and go, oh, this is 4 over 4. Right, we start at 0. And then you get to 5 pi over 4, well, you go up this way. That's going to get to 4. And I gotta go a little past it. 5 pi over 4. So it's in quadrant 3. And that has big ramifications. It's a mix of positive, negative, all depending on what you do. But the key here is understand how to draw radians. And to me, the trick is common denominator. Let's do a few more quick examples. Let's draw, so here's 0, here's pi. Again, that's all I really care about. Let's draw 11 pi over 6. Right, so again, common denominator, I'm like, okay, pi over 6. Here's my pi, make that 6 over 6. So let's talk about what that means first, right? So first, this right here, if I was doing a line there, would be 5 pi over 6. You always do one less or more. This right here would be a little bit past, so 7 pi over 6. I need to get to 11, so this is not good enough. So I go 6, I could go another 6, 12 pi over 6, right? 6 plus 6 is 12 pi over 6. Also known as 2 pi. Right, so this is 12 pi. A little less would be 11, which is what I want. And a little bit more would be 13. So quadrant 4, 11 pi over 6. Right, so it's all about common denominators. 6 over 6, 12 pi over 6, a little less, 11 pi over 6. Let's do one more of these, and then we'll move on to grander things. Let's draw pi over 3. So here's the trick. Right, if it's a 1 on top, you see pi, quadrant 1. I don't care what it is, right? So pi over 3 is in there. If I gave you pi over 4, hey, that's in quadrant 1 also. What's the difference? Pi over 3 has a 60-degree reference angle. Pi over 4 has a 45-degree reference angle. But they're both in quadrant 1. So if you don't see a number on top, it's automatically quadrant 1. So that's how you draw radians. So with all that in mind, we're finally able to move on to how to solve a unit circle problem, like how to start it. So, like I said, I'm gonna do my method first, and then we're gonna do the table method. I'm pretty much gonna stick to the table method after that, because I think that's the way most people are gonna do it. But if you're doing the triangle method, it's a little more advanced. Triangle method, so cool. With the triangle method, you also got to memorize a couple more things. And the main thing with the triangle method, the thing you have to memorize are those special triangles that are in geometry. So again, if you're going to do this way, you have to be really good at the special triangles. Specifically, I'm talking about 30, 60, 90 triangle, which I just like to call it a 30 triangle. So that's a 30 degree, 30, 60, 90. Opposite to 30 is 1. 30 is small, it gets to 1. Hypotenuse is always 2. And my adjacent sides are at 3. So I consider that a 30 degree triangle. It's a 30, 60, 90 triangle. And then we're going to talk about the 60, 30, the same triangle but with the 60. Right, so looking at it from the upper end, the 60 degree triangle. Now 60 is big. So 60 gets the rad 3. Hypotenuse is always 2. My adjacent's 1. Right, so for me, the key to memorizing these triangles, if you're going to do this way, is that just keep in mind 30, opposite 30 is the 1 because 30 is small. Opposite 60 is the rad 3 because 60 is bigger than 30. And hypotenuse is always just 2. Right, there's one more triangle if you haven't noticed. We're missing that 45, 45, 90 triangle. Like that. Now 45, 45, the key thing about that, main characteristic, it's an isosceles. It's 45, 45. So these sides are the same, so 1 and 1. And hypotenuse is always 2, but in this case, it's radical 2. Alright, so 45 is a special one. Always think about it, it's isosceles. It's like a Siamese twin or something. So you get 1, hypotenuse is radical 2. Right, so notice how the hypotenuse is always a 2. A couple little tricks I always do myself. Like there's only one radical in the problem, right? So if you're doing 36, 90, it's a radical 3. So that means hypotenuse is going to be radical 2. If you're doing 45, 45, 90, it's 1 and 1. So that means your hypotenuse, which is always 2, has to be radical. Right? There's always one radical. In the 30, 60, 90 one, the rad 3 picks it up. So that's the bonus. If you're doing the triangle method, you have to have these memorized. If you don't know these, then don't even bother. Go do the table method with everybody else. But if you're doing triangle method, you have to do this. The benefit of the triangle method is that, I mean, it's kind of the natural way we're supposed to be doing this. And if you get good enough, you just have this memorized. Like when I do it, I actually don't draw the triangles. I just set them in my head. So let's see how this works. Let's say I want to do sine of 60 degrees. So the way this works is this. Right, let's draw a little 60 degree triangle. So here's 0, right? Here's 90. 60 to go in here somewhere. Doesn't really matter. That's my reference angle, 60 degrees. What we do is we draw a triangle. Since that's 60, I have that memorized. It's radical 3. My hypotenuse is 2. The other side's 1. Now we get to the sine part. Right? Sine is SOHCAHTOA. Opposite of hypotenuse. So, opposite of hypotenuse. Rad 3 over 2. Right? And that's how you do the triangle method. We're going to do a couple more examples, but that's the general gist of it. You have these triangles memorized. So if I say something like sine of 30, you don't even need to draw it. You know, oh, 30, opposite 30 is 1, hypotenuse is 2, sine 30 is 1/2. Sine of 60, oh, opposite's rad 3, hypotenuse is 2, rad 3 over 2. Again, let's do a few more. Let's do a couple more examples, then move on to the table method. So let's do a cosine of 2 pi over 3. Right, so again, the way this works, if I'm doing the triangle method, is I draw it. Hopefully better than my drawing. Say 0 is pi. Again, the way I'm gonna figure out where no matter what you do, you gotta figure out where 2 pi over 3 is. I like to make this 3 over 3, common denominator. We're going this way. I'm a little less than 3. I'm at 2, so right here. If I'm doing the triangle method, I make a little triangle here. Figure out the reference angle. It's in radians, so if it's over 3, it's automatically 60. And again, if you're doing the triangle method, you have to know the triangles. If you don't know them, don't do this way, right? 60 is rad 3. Hypotenuse is always 2, and this is 1. Now there's one thing here. Don't forget we're doing an XY axis, right? Like an XY chart. When you do an XY chart, you go to the right, it's positive. When you go up, you're positive. When you go to the left, you're negative. And when you go down, you're negative. So see this graph here? We went to the left. That's actually a negative 1. You went up, positive 3. Hypotenuse is always positive. That's something to keep in mind. So hypotenuse is always positive. Now that I got that, I want cosine. So SOHCAHTOA. So adjacent over hypotenuse. -1/2. That's the triangle method in a nutshell, right? It's if you have to know your triangles, key thing. They have to know how to draw it. Once you do that, it's just okay. I know my triangle. I draw it. I make sure I know positive, negative, and then you work it. Let's do sine. Something we haven't talked about yet. Let's do sine of 3π/2. So I draw this 0, pi, 2π. Now 3π/2 is actually not going to be any one of those. Here's 0. Here's pi. This is π/2. And this is 3π/2. So we're following on what we call a quadrantal angle. We're following actually one of the lines. So those are special, and we haven't talked about this yet. So the way those work is, don't forget we're doing a unit circle. So we went it's a unit circle. Unit circle. Right, so we went 1 unit this way. That point is 1, 0. We're going 1 unit up. So like normal xy point, it's 0, 1. 1 to the left, so -1, 0. Remember, it's normal xy chart, and then 1 down. 0, -1. Alright, so normal xy chart. So how do I figure out what sine is? Well, there's this rule we haven't really talked about yet. We should know from the review that sine is always the y value. Kids in my class know I like to say siney. That's how I remember, siney. You never forget. I did a true story. I did that all through high school and college and my adult life. But let's move on. Siney. And then cosine has to go with x. And then here's a general that you actually do find your formula sheet. Tan is sine over cosine. Also known as sine e over cosine x, so y over x. Right? Sine is y, cosine is x. So if I want to do any of those points, if you ever get a point that lands on one of these things, you just got to remember, oh, it's a unit circle. What are the points there? Sine is y value, cosine is the x value. So my example here, sine of 3π/2. Here's 3π/2. And I want the y value, -1. That's how you do sine 3π/2. That's how you do a quadrantal angle using the triangle method. So that's the triangle method. Again, we're going to do more examples in class, any way you want to do it, but that's the general gist. You draw triangles, you have to have those 3 triangles memorized. Super important. If you can't do it, don't do this method. And then it's just drawing it, right? If you're in a quadrant, don't forget the negatives if you're certain quadrants. The more you practice, the better you get at it. And again, if you get really good at this, I mean, you get to the point where it's like me, it's like kind of the Matrix. You don't have to draw it anymore. It's just, you can just draw in your head. Anyway, that's the triangle method. Let's move on to the table method. Okay, method the table method. Again, I think this is the one that most people are probably going to do. It also requires some memorization, probably the least amount. So the table method is this. We draw a little table. So, this is going to be a tough. Boom. Let's see, sine, cosine, tan. Not the best, but whatever. Sine, cosine, tan. Draw a little table. We're going to have 0, 30, 45, 60, and then 90. Now don't forget, those are, and we also know that we should know those in radians off automatically. Like 30 is pi over 6, 45 is pi over 4, 60 is pi over 3, 4. This is 90 is pi over 2. This is just 0. 0. So the table method is this. It's all about, the key is right here at sine. If you can get sine down, then you get the table method. And so it's not that bad. So trick is just memorizing sine right here. So how does this work? Well, sine of 0 is, so it's all about you count up. So that's the key. Sine, count up. So sine starts at 0. That's interesting. It made a hexagon. Man, my circles are so bad it made a hexagon. Okay, let's just ignore that. So sine of 0 is 0. Sine of 30 is 1/2. Sine of 45 is rad 2 over 2. Sine of 60 is rad 3 over 2. And then sine of 90 is 1. So that's the key. If you get that down, you start low and go high, right? Sine 0, 1/2, rad 2 over 3, rad 2 over 2, rad 3 over 2, 1. If you get that down, you're going to be fine with the table formula. That's the only thing, that's one of the few things that I memorized for a table formula is this. right? So 0, and notice they're all over 2. So 0, 1 over 2, 2 over 2, 3 over 2, and then 1. It works out. So 0, 1/2, rad 2 over 2, rad 3 over 2, 1. Because once you get that, cosine is just the opposite, just flip it. So 1, rad 3 over 2, rad 2 over 2, 1/2, and 0. Right? So once you get sine, you just flip it to get cosine. Tan is sine over cosine. Right? We talked about it a little second ago. It's still right here. Hey, hi. Right? So you just put sine over cosine. 0 over 1, or hexagon over 1 in this case. 0 over 1 is 0. 1/2 over rad 3 over 2. So what happens there, the 2's just kind of cancel out. You get 1 over rad 3. Some people call that, they rationalize and get rad 3 over 3. Either way is fine, especially in IB. Rad 2 over rad 2, just 1. Rad 3 over 2 over 1/2 is just me rad 3. Again, the 2's cancel out. And then 1 over 0 you can't do. You can't divide by 0. It's crazy talk. Undefined. And that's the table. So the way the table works, anytime you have to solve something with a table, you just draw the table. You draw it once, right? If you have a formula sheet, you just draw it once, then you can just refer to it. Now, that's a table. There's one more thing with the table to know. And that's, we haven't really talked about this yet. We're going to talk about it more in a little bit. That is, it's a horrible straight line. Here's my chart. That is all students take calculus. What that is that's a shortcut chart to tell you where each trig function is positive. So in quadrant 1, they're all positive. In quadrant 2, anytime you go quadrant 2, only sine is positive. In quadrant 3, only tan is positive. And in quadrant 4, only cosine is positive. So again, this all students take calculus is whatever you want to use. Your book says all silly turtles crawl, which doesn't make sense to me. Sea turtles, yes, but not silly. Anything you want to use, all students take calculus is the general standard one. It just lets you know where stuff's positive. And what equally important, right? In quadrant 1, they're all positive. In quadrant 2, sine is positive. But that means that cosine and tan are negative. Quadrant 2. Right, when you go to quadrant 3, only tan's positive, the other 2 are negative. Quadrant 4, only cosine is positive, the other 2 is negative. So these are the 2 things you need if you do the table method, right? So you need to know how to build a table. Start with sine, start 0, climb up to 1, switch it for cosine, and then tan is sine over cosine. And you need to know all students take calculus. And by the way, everybody needs to know all students take calculus. We're going to use it in a bit. So let's do an example using this. So let's do sine, so make something up. Sine of 210. So if you're doing sine of 210 using the table method, first you got to draw it. You got to know what quadrant you're in. And you got to know the reference angle. So draw it, 0, 180. Right, remember going this way. Here's 270. 210 will be over here somewhere. 180 and 210 is 30 degrees. So you look at your little table, 30 degrees. Sine is 1/2. Right? Now, you have to keep in mind, is it positive or negative? We're in quadrant 3. Quadrant 3, only tan is positive. So my sine value here is negative. That's the table method. Right? Let's do another example. Let's do a tan of, what haven't we done yet? Let's do 7 pi over 4. Right? So 0 pi. So this is 4 over 4. Now remember, I gotta go 7. So 4 over 4. Go around again. 8 pi over 4, also known as 2 pi. So we haven't reached here yet. We're a little short. So we're down here in quadrant 4. It's over 4 though. Tan at 4 is 1. So I know it's 1. And then it's in quadrant 4. Remember, quadrant 4, only cosine's positive. So it makes my tan negative. And that's the table method. Like, that's the way it kind of works. Right? You just figure out what quadrant you're in, draw it. Once you figure out the quadrant, you just look at the reference angle, you got your answer. So again, I don't care which way you use. Table methods, I think the way most people are going to use it. But either way is fine. Whichever, you just kind of pick away and be good with it. Okay, so let's move a little more advanced. Now that we know how to do the unit circle, hopefully, we'll practice some more in class. Let's talk about how to solve problems using unit circles. So how to go backwards. So our goal here is to be able to solve trig equations. And the way we do this is we just want to get sine by itself. So let's try to get sine move stuff over. So let's add 1, so some algebra. 2 sine x equals 1 divided by 2. sine x equals 1/2. So the way this works, again, it all kind of depends on how you do the other one. If you have this memorized, if you did method 1 memorized, you gotta think back the opposite. Where does sine equal 1/2 at? What are your answers? Right? The whole point is to solve this. Our answer here should be radians or degrees. Right? Going backwards. So if you memorize it, just go backwards. If you're doing a triangle, well, we gotta do actually either way. No matter which way, if you're doing triangle or the table, you gotta do all students take calculus. So all students take calc. And what we want to do is look at what we have. This is a positive value. So remember, all students take calculus. This tells you where stuff's positive. We're doing sine, so we're going to be positive in quadrant 1 and in quadrant 2. Now if I'm using triangle method, what do I do next? Is I go, okay, this is sine, so I know it should be opposite of hypotenuse. If you're doing the triangle method, based off that alone, you should know, wait, opposite 1, 2, that's a 30-degree triangle. Right? Because if it was rad 2, I know it's 45. If it was rad 3, I know it's 60. But it's a 1, opposite of 1 is 30. Which makes your answer, from here, 30 degrees. Now the way we get the answer right here, some people have a hard time with this, is remember, we're trying to get to this line right here. This is 180. So from here to there, right, you're 30 off. So this is 150. Right, you're 30 away from 180. So 30 and 150, if you're doing degrees. If you're doing radians, you gotta remember 30 is pi over 6, so this is pi over 6. This is pi, also known as 6 over 6, and then you're 1 less, so 5 pi over 6. That's how you do in radians. If we're doing the table people, very similar idea. Oh. Sine, cosine, tan. I'm still focusing on the sine one, right? So 0, 45, 30, I can count. 45, 60, 90. Sine is 0, 1/2. Rad 2 over 2. Rad 3 over 2. And 1. Now, so what we do is look at, it's a very similar idea, right? We look at, okay, my answer is 1/2. So 1/2 sine relates to 30. So I know it's a 30-degree angle. Next thing you do is all students take calculus. I'm not sure what happened there. And you gotta remember, okay, it's exact negative there. It's here and here. 30 and 30, because that's what I know, right? The only difference between this is that instead of using triangles to figure out 1/2 is 30, you base on the chart. Oh, so 30, 30. Again, 30 and 180. 150, sorry. 180 minus 30. So that's the idea. Let's do another one. So this is tan 1 here. So same idea, try to get tan, because we're going to try to get tan by itself, minus rad 3 from both sides. Tan of x equals negative rad 3. I'll do this one just a chart, because that's the way I think most people are going to do it. So you build your chart, sine, cosine, tan, 0, 30, 45. 60, 90, plus people need to practice the chart, right? So sine is 0, 1/2, this is memorization, rad 2 over 2, rad 3 over 2, 1. Cosine you go backwards, right? So you just flip it, so 1, rad 3 over 2, rad 2 over 2, to rad 2 over 2, 1/2, oh, 0. Then remember tan, you put sine over cosine, that's the rule for tan, it's sine over cosine, y over x. So 0 over 1 is 0. Over here, the 2's cancel out. You just get 1 over rad 3. Or rad 3 over 3. These two cancel each other out. You get 1. Rad 3 over 1/2 is this rad 3. And then that's undefined. Right? Now look at my chart. My answer is rad 3. So I know it's going to be a 60-degree triangle, right? That's what that tells me. So I just got to figure out where my 60-degree triangle is negative at. So to do that, we do all students take calculus. All students take calculus. Again, this tells me where tan's positive. So tan is positive in quadrant 1, because all, and tan's positive in quadrant 3, because tan. T stands for tan. So if I'm positive at these two, I must be negative at these two. So that's where my graph's going to be, because my answer here is a negative rad 3. So quadrant here, right? So I already know this is going to be 60 and 60. So again, the way we do this is 180. We are 60 away, right? We're 60 off of 180, so that's 120. Right here is the 0 and 360. So we're going all the way around. We're 60 away from 360, so we're at 300. That's the way you do the answer. In radians, 0 pi, right? We should know 60 is pi over 3. So this is 3 over 3. 1 less. It's 2 pi over 3. We had to go around to 2 pi, also known as, it's in common denominators, 3 over 3, 6 over 3. And 1 less would be 5 pi over 3. So that's the answer in radians. Now you notice here, if you look up here, they went from 0 to 4 pi. I only went to 2 pi. So all that means I have to go around again. So you just do it again. So 2 pi, 3, so this is 6 pi over 3, this will be 9 pi over 3, which is 3 pi. So 1 less would be 8 pi over 3. So now all the way to 4 pi, go around again. So 6, 3, 6, 9, 12 pi over 3, which by the way is 4 pi, which is what I need. So 1 less would be 11 pi over 3. So technically you should have 4 answers, because they want you to go all the way to 4 pi. I'm gonna do one more. This video's getting a little longer already, but let's do one more just so we haven't talked about the rest in class. Let's talk about this one. So the reason I want to talk about this one is that there's this stuff in the middle. Here's the key of this. Ignore it. Ignore it to the end. At the end we'll pick it up. So we're just gonna pretend it's not there. Let's make this like it's a. Most people use like a u. So right now we have this. Rad 2 cosine plus 1 equals 0. Right? Just ignore it. Pretend it's not there. Solve it like normal. Subtract 1, divide by rad 2. So cosine equals negative 1 over rad 2. Again, if I'm going to solve that, you can do it any way you want. Let's do a little chart real quick, because that's the way I'm trying to get most people before we can do it. 0, 30, 45, 60, 90, 0, 1/2, rad 2 over 2. Rad 3 over 2 and 1. You just flip it. Right, I'm not going to go the rest because all I need is cosine of 1/2, 1 over rad 2. And that happens. So 1 over rad 2, you notice I don't see it down here? It's because on the table it's rationalized. This is the same thing as multiply both sides of rad 2 over rad 2. Negative rad 2 over 2. So you got to know those are equivalent. And they'll use this a lot. So it's actually 45. So just like before, it's a negative rad 2 over 2. So I just got to figure out what cosine is negative. All students take calculus. Again, this tells you where stuff's positive. A is always positive, always. That's what A stands for. We're doing cosine, so quadrant 4 is now positive, which makes this and this negative. I want the negative ones, right? This is the negative 1 over rad 2. So I'm looking for these two. We're in radians. We're pro. We can do it in radians, right? If I'm doing radians, 45 is pi over 4. That makes this is pi. So we're gonna make 4 over 4, common denominator. 1 less will be 3 pi over 4. 1 more will be 5 pi over 4. So that's our answer, right? We get u equals 3 pi over 4 and 5 pi over 4. But we're not done. Remember, I said ignore this to the end. Now it comes back. It's like, okay, we solved it except for this part. Let's put that part back. This is actually x minus 3 pi over 4 equals 3 pi over 4 equals our two answers. And then from here we just solve, right? Add 3 pi over 4 to both of them. It's like a normal problem. We're going to get x equals 6 pi over 4 and 8 pi over 4. 4. And that would be the idea. Again, it actually goes to 6 pi. It's supposed to keep on going around until I get 6 pi, but I think you guys get the gist. And we're going to talk about this more in class. But that's the general idea. Again, I don't care which way you do the unit circle, but you have to pick a way and know how to do it. I think most people are going to find the chart's probably the easiest way, and that's fine, right? All you have to do is, once you get your format sheet, just write the chart down. You have it memorized, you can use it for the whole test or quiz. So that's it.